So here's some guidelines for how to restrict the domain. There's no specific rules, so there's often a few ways to do it, and you need to just make some sensible choices based on what you're using the graph for. So you want to generally make the restricted domain as large as possible. There's no point having your new graph be only a really tiny little section. It might be helpful to include x equals 0. Positive numbers might be more relevant, so depending on your application of how you're using the graph, have a think about that. But here's the key thing. What we want to do is look for stationary points. Now, when we first looked at restricting the domain in chapter 5, that was kind of a little teaser leading to this. But the reason we didn't get to this point then is because we didn't know how to differentiate at that time. Now that we know how to differentiate, we know how to find turning points in curves. So if we've got some curve that's even a cubic curve, say, we now have a good method of finding exactly where the gradient is horizontal or where the gradient is 0. And effectively that finds us our high and low points or our dips and our troughs. So once we know where those are, I think you can see that if we're looking for a place that a curve is going to fail a horizontal line test, it's going to fail them on either side of one of these points. You can see here that if I go to put a horizontal line through, say, a cubic curve like this, then if I put it through anywhere here, it's failing the test several times over. Even if this section here continued to go down, it's around the turning point here that we're failing the test. So we've looked at what we could do to restrict the domain of simple graphs like parabolas. If we've got something like y equals x squared, we've got two choices. We can either have the right-hand arm of the parabola, or we could take the left-hand arm of the parabola. So you can see now it's no coincidence that where we choose to make our cut and say we'll have this section or that section, we make our cut on the turning point or on this stationary point. And the reason we make it there is because that's where the gradient is 0. So that's where a horizontal line will start if we go above or below it, depending on if it's upright or upside down. That's where it will fail that horizontal line test. Now, when you're looking at something like a cubic curve, it might do something like this. We can see where the turning points or the stationary points are. We've sort of got a couple of choices here. One choice would be to use just this upper arm from there upwards and ignore the rest. Restrict the domain to whatever this value of x is or greater. Another choice would be to use only the lower section and ignore everything else. Or a third choice would be to use only the middle section. Now, I've written here that choosing an interval can be smart at times because it avoids the temptation to make a function that's got discontinuities in it. Now, discontinuities are just gaps, aren't they? So let's consider what would happen if I said, all right, I'm going to have just this part from here up, whatever that value of x is, upwards. I'm not going to have the rest there because it fails a horizontal line test all through here. Well, what if someone else said, oh yeah, but it doesn't fail it once you get over to like level with there. You could use this bottom part too. It's sort of tempting to think, oh yeah, that's making the domain as large as possible. That's a good consideration. Sure, but now you've got a little issue in that you've got values of x from here upwards and from there downwards, and you've made now, when you turn that into your inverse, you've made a function, but it's got a whole chunk for which it's not relevant. And perhaps the most relevant part might have actually been the middle, and it might have been more sensible to just choose from there to there. So as we look at each inverse situation, I think you'll get better at making a sensible choice about how to restrict the domain. When we look at the trig graphs, there's just one way that we're going to do it every time. Let's have a go now at restricting the domain of this function so that its inverse is also a function. Now, the first step is to look at it and say, what sort of graph is this? Well, I can see that it's an upright parabola. So if you can graph it, I think that's the first step done. We know that we want to look out for those stationary points or turning points. So I really want to find where the vertex of this thing is. Now, at the moment, it's arranged in vertex form, where I can see straight up that the vertex is going to be 1, 2, because it's in that form x minus h all squared plus k, where the vertex is hk. But if we didn't know that, what would we do? Well, I think we'd just do a rough sketch on the side and say this is a lot like y equals x squared, except we've taken x and we've changed it into x minus 1, and that moves it 1 unit to the right. And we've also shifted the whole thing up too. And so that puts it up here so that our vertex is up there. And it's an upright one, I can tell, because if I expand it out, then the coefficient of x is positive. So I've got some sort of graph like this, okay, and I can see the vertex. So my obvious first choice is to say I need to restrict the domain of this thing and either use the right-hand arm or the left-hand arm. Which one shall we pick? Let's go with positive numbers, nice and simple. We could have picked either one, but I need to make a choice. So I'm going to put my restriction in here and say that x has to be greater than or equal to 1. Because if it's not, if I don't restrict it like that, then when I make the inverse, it won't be a function. So now the next step, to make my inverse, this is effectively a y, isn't it? I swap the y's and the x's. So I write x where there was a y and y where there was an x. And importantly, write down your restriction on your original right there so that then you won't forget to write down that we need to switch the restriction as well. So now y has to be greater than 1. Now when we rearrange this, we can keep that in mind when we need it. So first thing to do, let's subtract 2 from both sides. Now let's take the square root of both sides so that we just have y minus 1 here. Now when you take the square root at this stage, wouldn't you normally consider the plus and the minus version of that? Well, we're not going to do that this time. Why not? We've already considered that y has to be greater than or equal to 1. Now if y is greater than or equal to 1, then it's at least 1 or bigger. So 1 minus 1 is going to be positive, isn't it? And you can even rearrange this if you like and say, what's y minus 1 going to be? Well, I've just subtracted 1 from there, so I can subtract 1 from here, and I've got my new restriction. So now when I consider here, I know that this right-hand side is positive. It's 0 or greater. So I don't need to consider the negative square root here. I've just got the positive one. And if I'd made my restriction x being less than or equal to 1, then I would take the negative square root here, and I'd consider that y minus 1 had to be less than or equal to 0. So I don't need any sign there because I'm only looking at one arm, and I've decided what that arm is. Now I need to just get the y by itself, so let's add 1 to both sides, so you can write it like this. Or obviously we could have had these terms switched around, up to you. Now when we look at how to graph this, at first you might think it looks a little confusing, but remember in its own right, we already know the graph y equals the square root of x. It's just one arm of a sideways parabola. And all we've done here is we've shifted it 2 units to the right, which means it's come across here. And then we've moved it up 1. So that whole section has come up to here, and it's looking like that, and it's going through this point 2, 1. Or if we'd already graphed our parabola and we're wanting to graph its inverse, then we can reason that we've ignored the left-hand arm of the parabola, so we've really just got the right-hand arm, and our new graph should be quite easy to draw, especially if you're good with those visual art skills, just by making a reflection around the line. We could see there that it was going to go through 2, 1, just as this one goes through 1, 2, and it's going to have that same basic shape that its inverse had, but it's going to be a reflection around that line y equals x.